students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is write as a single simplified logarithm with coefficient equal to unity, that is equal to 1. Now don't get scared by looking at this term simplified. You have enough knowledge on logarithms to simplify logarithmic expressions. And in our today's session, we will be seeing that we will be using a particular law, or not a particular law, but a combination of laws on logarithms that we have learned so far. And we will be needing some knowledge on the laws of exponents, as well as we will be needing some knowledge on algebra and algebraic identities, because there will be 2 questions solved and explained in this session, and the second question will be containing variables. Okay? So without any further delay, let us start with our today's session, and I would definitely be asking you to stay till the end of this session so that you know how to simplify logarithmic expressions which contain some variables as well. Not only the numbers, the first question will be having the numbers, only the numbers, and the second question will be having the variables as well. Okay? So we start with our today's session. Question number 1. Rewrite as a single logarithm with its coefficient equal to 1. This is the given logarithmic expression which contains 3 terms, and we have to give the answer as a single log term with a coefficient equal to 1, because over here the first term is having a coefficient of 4, the second term is having a coefficient of 3, third term is having a coefficient of 2. So we have to have a single log term in place of 3 log terms, and we have to have a coefficient of 1, and not only that, we have to give the answer in the simplified logarithm or simplified log term. Okay? So let us start with the answer. This actually, since the coefficient should be made equal to 1, we cannot keep these coefficients. We have to take them to the power part of the exponent, the arguments. So 4 comes as the power of 15. It is log of 15 to the power of 4. Minus 3, this will also go to the power part or the exponent of this 3. So it is minus log of 3 to the power of 3. And finally, it is minus log of 5 raised to the power of 2. We have to do this whenever, and also when you join. Next thing that we will be doing, of course, now we have to get a single log term, so we have to join, combine. So how do we combine? We know that log of a plus log of b is equal to log of a times b. And since I have not written the base explicitly, the base is of course equal to 10. Whenever the base is not written, you have to assume the base to be equal to 10. Okay? So log of a plus log of b equal to log of a times b, and log of a minus log of b is equal to log of a divided by b. We have learned these 2 laws of logarithms, the multiplication or the product law or the rule of logarithm, and the division or quotient rule of logarithm. So over here we are having the minus sign, so obviously we will be needing the quotient rule or the division rule, and in the product rule or the quotient rule, whichever you take, you will be finding the coefficients of the log terms to be equal to 1. So if you have some other coefficient, first thing that you have to do before combining, you have to take the coefficients to the power of the argument. Okay? You have to write the coefficients as the power of the exponents of the arguments. Okay? And only after that can you combine the log terms. And over here, we are having, this one is having a plus sign, and these 2 are having minus sign. So let us combine these 2 first. This is log of 15 to the power of 4 minus log of 3 raised to the power of 3. So it will be equal to log of 15 raised to the power of 4 divided by 3 raised to the power of 3 and minus 5 log of 5 raised to the power of 2. We are having now, instead of 3 terms, we are having 2 terms. Log of 15 to the power of 4 divided by 3 raised to the power of 3 minus log of 5 raised to the power of 2. Okay. And now we have to combine. Now we are having only 2 terms. So we will be, since they are connected by the negative sign, so this 5 raised to the power of 2 will also be coming in the denominator, because it will be divided, the first argument divided by the second argument. That is how we combine when the 2 log terms are connected by a minus sign, right? So that is the quotient rule. So this becomes log of, and 15 can be written as, why am I writing 15 as 3 times 4 whole raised to the power of 4? You will, sorry, it is 3 times 5 whole raised to the power of 4. You will be knowing after this step, of course, very soon. So because we have to simplify, because we have come to a single log term having a coefficient of 1. And you can just find what is 15 raised to the power of 4 and what is 27 times 25. And you can write the numerator and the denominator. But that will not be a simplified log term. It will be a single log term with a coefficient equal to unity, but not a simplified log term. That is why I have written, we have to simplify as well. So that is why I have written 15 as 3 times 5, because the denominator is also having 3 and 5. Okay. So now we will be using one law of exponents, and because this is equal to, this can be written because of this law, a times b whole raised to the power of m is equal to a raised to the power of m times b raised to the power of n. So 3 times 5 whole raised to the power of 4 is equal to 3 raised to the power of 4 times 5 raised to the power of 4. And the denominator is the same, 3 raised to the power of 3 times 5 raised to the power of 2. Okay. And now again we will be simplifying this argument of the log term by using the properties of exponents. 3 raised to the power of 4 divided by 3 raised to the power of 3 will be equal to 3 raised to the power of 4 minus 3. And this is 5 raised to the power of 4 divided by 5 raised to the power of 2 is equal to 5 raised to the power of 4 minus 2. And this is log of 3 raised to the power of 1, or simple 3 times, and of course there is this multiplication sign in between, and it is 5 raised to the power of 2. So what is 3 times 5 raised to the power of 2? 5 raised to the power of 2 is 25. So it is log of 3 times 25, which is equal to log of 75. Okay. So this is the simplified version. A single log term containing the coefficient equal to 1, and it is the simplified form. It is in the simplified form. Okay. So this is our final answer for the question number 1. And now coming to the question number 2. Rewrite as a single logarithm with its coefficient equal to 1. 2 times log of x plus 1 plus log of x squared minus 1, this is having a coefficient of 1, minus 3 times log of x plus 1, and x is greater than 1. This has to be satisfied. X is a variable, but x cannot have any number equal to 1 or less than 1, because if it is equal to 1, this will be 1 minus 1 equal to 0, and you cannot have a 0 as the argument of a log function. So this should be maintained, this should be satisfied, that x cannot have a value equal to 1 or less than 1. X should be greater than 1. Okay. And of course, since the base, I have not written any base, the base is missing for every log term. the base is assumed to be equal to 10. Okay, and again we will be doing the same thing because we cannot keep the coefficient, so we will be taking the coefficient and making them the exponents of the arguments. So the first term becomes log of x plus 1 whole raised to the power of 2 plus this had a coefficient of 1, so it stays as it is, plus log of x to the power of 2 minus 1, and this one, the third term, is minus log of x plus 1 whole raised to the power of 3. Okay, and now we will be combining them. First of all, we combine these two. They are connected by this plus sign, so the arguments will get multiplied. So it is log of x plus 1 whole raised to the power of 2 times x squared minus 1 and minus log of x plus 1 whole raised to the power of 3. And because these two, now we are having only two log terms and connected by this negative sign, so the x plus 1 whole raised to the power of 3 will be coming in the denominator of the argument. But before doing this combining part, let us do some simplification of this argument for the first log term. So this can be written as x to the power of 2 minus 1, x squared minus 1 can be written as x plus 1 times x minus 1. That is why I had said that you will be requiring some knowledge on exponents. This is one of the laws of exponents, and also this one I have not written the law. It is a raised to the power of m divided by a raised to the power of n equal to a raised to the power of m minus n. I have used that law as well for this question, and over here I am using the algebraic identity a squared minus b squared equal to a plus b times a minus b, and minus log of x plus 1 whole raised to the power of 3. And now x plus 1 whole raised to the power of 2 times x plus 1 will be giving us x plus 1 whole raised to the power of 3. So we are having, now we will be combining these two terms. It is log of x plus 1 whole raised to the power of 3 times x minus 1, and in the denominator this part comes, it is x plus 1 whole raised to the power of 3. So we can cancel these two. Okay, so they get cancelled and we get the final answer as log of x minus 1. Okay, so we had to do all these steps because of this word simplified logarithm. Otherwise, we could have just taken these two, x plus 1 whole squared times x squared minus 1 divided by x plus 1 whole raised to the power of 3. We could have given that. Of course, there should be the log word in front, and the base is of course equal to 10. We could have written that as our final answer because that would have been a single log term with a coefficient of 1. But that would not have been a simplified log term. Okay, so this is the simplified single log term having a coefficient equal to unity or equal to 1. Okay, so students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.